All right, now let's go into the actual problems that you're gonna see on this assignment. So, two 8th grade classes are selling raffle tickets to raise money. One class is selling tickets for $4.50 each, has already raised $2.50. The other class is selling tickets for $5 each and already raised $125. Which equation can be used to find T, the number of tickets each class needs to sell so that the total amount raised is the same for both classes? So when it comes to word problems, you guys, I suggest you read it a couple of times. The first time we overlooked some important information. This time we're gonna read with a purpose. We're gonna highlight and underline important information. So two 8th grade classes are selling raffle tickets to raise money. One class is selling $4.50 each. That seems to be important to me. And the word each is gonna be one of our keywords. And already raised $250. So that's just one class. The other class is selling tickets for $5 each and has already raised $125. So I like to underline the question, see what it's asking. Which equation can be used to find T, the number of tickets each class needs to sell, so the total amount raised is the same for both classes? So here we have one class and the other class. I like to label what two things we're talking about. So let's concentrate on sentence by sentence. Let's see what we can pull from one class is selling tickets for $4.50 each and already raised $250. When I see the term each, I know that that's gonna be constantly changing. And so they're telling us that they already have $250. So we know it's, and we're gonna use T as a variable. The question tells us to use T. And they already had $250. Now let's look at the other class. The other class is selling tickets for $5, and there we go, the word each. So that's gonna take our variable T and already raised $125. So they already have this $125. Which equation can be used to find T, the number of tickets in each class needs to sell so the total number raised is the same? So then what is same? If we translate this to an equation, same is gonna be equal. So pretty much have the equation. Because it's multiple choice, if you create this, just look at which multiple choice matches the equation you already created. And you can pause this at any point, you guys, and rewind and make sure you're doing the work along. It'll help a lot. All right, so Samantha is ordering trophies for her school. Company P charges $4.75 each trophy and a one-time engraving fee of $28. Company R charges $8.50 for each trophy and a one-time engraving fee of $19. Which inequality can be used to find X, the minimum number of trophies that can be ordered, so that the total charge at Company P is less than the total charge Company R? So again, I'm gonna follow those rules, you guys. We're gonna reread this, but this time with a purpose. We know we're gonna have Samantha's ordering trophies. We have Company P that charges $4.75 each. There's that key term. And one-time engraving fee. That means that only charging you one time. Company R, so we have two companies, is charging $8.50 each and a one-time fee for $19. So that's the important information I took out. Now, let's underline which inequality. Notice this time they're using inequality can be used to find X, the number of trophies that can be ordered so that the total charge of company P is less than, there's another keyword chart, than the total charge of company R. So again, we're comparing two things. So company PN all right, those are the two things we're comparing. We're gonna take it sentence by sentence. Company P charges $4.75 each. Every time I see the word each, I'm already thinking that's gonna be my variable. And what variable are we using? X. And a one-time engraving fee. So X represents each trophy, right? So the engraving fee is gonna be the same regardless, 28. But then each trophy, they order 3, 4, 5. That's the X, that's what's changing. And then company R charges $8.50 each trophy. Again, that's the variable we don't know, but it can represent a number, plus 19. All right, so we have our equation, but now let's read the question. Which inequality can be used to find the minimum number of trophies that can be ordered so that the total charges of company is less than? So before I even put it in here, we're comparing company P to be less than company R. So if I want to say company P is less than, it's going to take the smaller part of this symbol. And so we say this is our final answer. I mean, it's already up here, but I like to rewrite it. 75 less than 8.50. And there you have it.